Okay, let's continue on with problems 6 through 10. It says here, table of values for continuous function f is shown above. If four equal subintervals on the interval from 0 to 2 are used, which of the following is the trapezoidal approximation of the integral from 0 to 2 of f of x dx? So again, this graph up here to the left here has no bearing on the actual function itself. It's designed just to show you again what the trapezoidal sum looks like. So we have the trapezoid here. The bases are the heights of the function, the y coordinates, and h is the difference between the x coordinates. And the formula for area of a trapezoid is going to be 1/2 the height times base 1 plus base 2. So we're using four subintervals here. So this is our first subinterval from 0 to 0.5. This is our second from 0.5 to 1, our third, and our fourth subinterval. Let's go ahead and calculate that. So our total area, the integral from 0 to 2 of f of x dx, is going to equal 1/2. Now the height for all of these is going to be 1/2 or 0.5 because that's the difference between the two consecutive x coordinates. I'm going to say it's 1/2 times. Now base 1 is the first y coordinate, base 2 is the second y coordinate, so we're going to go 3 plus 3 plus next trapezoid 1/2 times the height, which is 1/2, times the sum of those x coordinates, which is 3 and 5, or those function coordinates, sorry, y coordinates, plus 1/2 times 1/2 times the sum of the two bases here, which are 5 and 8, plus 1/2 and 1/2 times the last two bases, 8 and 13. I want you to notice just real quick how the inner function values are all counted twice, where the outside ones were only counted once. You'll see them here. And there's actually a nice little shortcut for all of that stuff. But if you see it, great. We could talk about it. Otherwise, we'll just do it this way here. Throw all that into a calculator. Do it out. Either way, we're going to get 12. All right, number 7, the function f is continuous on the closed interval 2 to 14. It has values as shown in the table above. Using the intervals that are given, 2 to 5, 5 to 10, 10 to 14. What is the approximation of the integral from 2 to 14 of f of x using right Riemann sum? So when we do that, this value here is irrelevant. So our integral from 2 to 14 of f of x dx is going to be, now again, this is a rectangle, so it's base times height. Base is 3 times the height, which is 28, plus our next base is 5 times the height, 34, plus the next base is 4 times the final height is 30. We go ahead and do that math, and we get 374. Number 8. If the integral from a to b of f of x is 5 and the integral from a to b of g of x is -1, which of the following must be true? Now, the first thing to note here is this. Just because the area from a to b is 5, it does not mean that you're looking at a graph like this, if this is, a and this is b, that this area is 5. It could look very much like this, where it drops down below and then comes up, where this would be 7, this would be 5, and this, let's say, would be 3. So we have 10 in terms of positive area, we have negative area of 5, and all told, we're looking at a sum total of the area of 5. So don't always think that everything's just perfect and nice. It is not, and that's going to really come into play in this. So number 1, is f of x always above g of x? After all, the integral of f is greater than the integral of g. Well, for this reason right here, it doesn't always need to be. We have no idea what these functions look like on the interval from a to b. All that we know is that the area is 5 and the area is -1. So this is not true. However, 2 is true because we have the sum and difference rule for integrals. It says the integral from a to b of f of x plus g of x is equal to the integral of a to b of f of x dx plus the integral from a to b of g of x dx. And therefore, that would be equal to 5 plus -1, which is going to be 4. So that is true. Here, however, for the same reason when we did derivatives, we couldn't just derive the product and derive the quotient. We had special rules for those. Same thing here when we get to integrals. We cannot integrate a product that way. So in this case here, 2 is the only answer. What are all the values of k for which the integral from -3 to k of f of x squared dx is 0? And again, we have that 0 property that looked something like this. If the integral from a to a of f of x dx is 0, so therefore this is only going to be true when the upper bound is equal to the lower bound, which would be at -3. All right. Number 10, if the integral from -5 to 2 of f is -17 and the integral from 5 to 2 of f is -4, what is the value of the integral from -5 to 5 of f of x dx? Well, the first thing we need to do is we need to adjust these bounds here. That is, I need to write this as the integral from 2 to 5, always moving from left to right, 2 to 5 of f of x dx. And remember, to switch the bounds, we must go ahead and switch the sign of the integral. Now we can use the property that the integral from -5 to 5 of f of x dx is going to equal the integral from -5 to 2 of f of x dx plus the integral from 2 to 5 of f of x dx. And so therefore that's going to be -17 plus 4 is -13. And that takes us through number 10. And we'll pick it up in the next video.